Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
If we assume that's the Bahamas, 544 miles per hour, 46, 56 degrees.
Thanks, Ron. The longer time goes on, time and, real time. So Ron said a few years. It was actually a dozen years ago that we first met. It's nice to be here with all of you tonight. Tonight, astronomically, is kind of a big deal. Got this thing called the supermoon tomorrow morning. Does everybody know what this is? Supermoon is when there's a full moon and it's really close to the Earth. When things orbit around the Earth, like a space shuttle or a spacecraft or a satellite or the moon, it doesn't always orbit in a circle. And there are things called apogee and perigee. Apogee is the top of the orbit, furthest away. Perigee is the closest. And tomorrow morning at like 7 a.m., the moon is going to be really close to the Earth, and it's going to be a full moon. So it's going to be like 33% brighter, 14% closer. If you can get up early, maybe, not too early for some of you, it's 7 a.m., you'll see this really close full moon. And you're not going to see this again till 2034. And the last time this happened that it was this close, 1948. Harry Truman was president. You know what also happened in 1948? 1948 was the year that the United States launched the first monkey into space, a rhesus monkey named Albert. And we've launched a lot of monkeys and people since. Albert did not have a very successful space flight from his point of view because he did not survive the flight. But he contributed to science, and all of us astronauts should really honor Albert, who died in space in 1948. But we're going to talk about a little more about space and people. But first, I want to tell you a little bit about our universe, right? Universe is a big place. Our universe is 13.9 billion years old. That's really old. And the Big Bang started 13.9 billion years ago, and the universe has been expanding ever since. And the universe is really, really big. And no matter where we look, in any direction, it's about the same distance to the end, though we're not in the middle. It's kind of a hard thing to wrap your head around when the edge of the universe is the same distance in any way you look, but we're not in the middle. And that has to do with how we're expanding. Think about a balloon expanding as you fill it with air, and we are one point on that balloon, and every other point on that balloon in a circle is equidistant from us. So the universe is 96 billion years across, billion light years across. Now, how big is a light year? Well, light travels 186,000 miles in 1 second. So a light year is the distance that light will travel in a year. And the universe is 96 billion light years across. It's really, really big. And there are a lot of galaxies in our universe. Ours is one of those galaxies. One of what we now just figured out, we just did a new calculation, and we have realized that there are now 10 times as many galaxies in the universe than we previously thought. And that number today is 2 trillion galaxies. And in each of these galaxies, there are hundreds of billions of stars and hundreds and billions more planets, potentially Earth-like planets. So our galaxy is one of these 2 trillion galaxies with hundreds of billions of stars. And our galaxy is a really big place. It's 100,000 light years across. It's a spiral, and we're about 1/3 to 1/2 of the way out on this spiral part of this galaxy. Now consider this for a second. This is the size of our galaxy. If our solar system's the size of a quarter, how big do you think our galaxy is? Well, it's the size of the United States. It's really, really big. And as humans, we want to explore this galaxy, and we want to eventually, maybe, explore this universe. But these distances are really hard for us to even comprehend. And when we think about Earth-like planets, planets like Earth or Mars that could potentially support human life, we now know, based on some recent research, that there are a lot of them out there. We have this telescope called the Kepler Planet Finder that's been looking for Earth-like planets in our galaxy in the vicinity of our solar system. And as we look around our solar system as we look around our galaxy close to our solar system, we realize that there are a lot of Earth-like planets. And when we extrapolate that number to the size of our galaxy and multiply it times the number of galaxies we think exist in the universe, we have now realized that there are more Earth-like planets in our universe than there are cells in every single human body on Earth. It's a really big number. There are more stars in our universe than there are grains of sand on every single beach and every single desert on planet Earth. Enormous numbers. But the closest star to Earth that isn't the sun is Alpha Centauri. And near another star called Alpha Proxima, we think there's an Earth-like planet there. And we would like to go to it one day. Now here's the problem. It's 4.24 light years away. And at the speed we can currently travel, which is about 35,000 miles an hour, you know how long it would take you to go 4.24 light years? About 80,000 years. So we're not going there anytime soon. But you know where we can go? We can go 140 million miles away. And that's where Mars is. And that's why one day, you know, we have sent a lot of stuff to Mars over the years. We landed Viking in 1976. The Phoenix Mars lander operated out of the University of Arizona. Landed in 2007, I think. 2007 or 2008. It landed. It was operated from here. We send a lot of stuff to Mars. We land stuff on Mars all the time. You know how often other countries land stuff on Mars? Never. Russians crash into Mars all the time. Over and over again, they keep crashing. They keep trying. You got to give them credit. They crash everything into Mars. Even the Brits, Beagle 2, crashed. You know what happened to Beagle 1? It wasn't a spacecraft, so it didn't matter. It was a ship. So Beagle 2 crashed. But we keep sending things to Mars. And one day, we want to send people to Mars. And it might happen here relatively soon. The U.S. government, the president, our president just said he wants to send people to Mars by the mid-2030s. Elon Musk, who runs a company called SpaceX and Tesla, he wants to send people to Mars in about 10 years. And I'll tell you what, if there's anybody on this planet that has the ability and the desire to do it, it's him. So we may actually see what's happening in this movie happen in our lifetimes. Certainly in your lifetime. Your lifetime. A lot of you will see people walk on Mars someday. So that's really exciting. Mars is a difficult place to live, as this movie shows, right? On Earth, we have 20% oxygen in our atmosphere. You know what Mars has? Less than 1%. We have very little carbon dioxide. Our carbon dioxide is like 0.04%. 0.04, less than 0.1%. You know what it is on Mars? 96% carbon dioxide. Difficult place to live, difficult place to survive. I think this movie does a really good job representing how hard it would be to live on Mars, and especially how hard it would be to survive if you were left by yourself. So please enjoy the movie. I'll be back to answer questions at the end. Thank you. So, you know, what I find the most fascinating thing about this movie is we could actually, as a country, we could actually do this. Right? We're getting pretty close. We understand the rocket science pretty well. The physiology we're trying to figure out, that's one of the reasons my twin brother spent a year in space, is to figure out the physiology in a study partly to do with me and him. We're identical twins. But you know the hard part about this is the political science. That's what we really got to figure out, is how do we get our nation behind a program like this. And I certainly believe, and a true believer, that the money we spend on our space program is a great investment. You know, every dollar we put into NASA, we get out tenfold in our economy over the next decades. So even though going to Mars would be really expensive, and it would be kind of hard to figure out, there would be a lot of challenges, we would learn so much about ourselves, about technology, we would invent new things, that it would be a big boost to our economy for decades. So we should do it. But there are challenges. You know, we just found water on Mars recently. NASA has confirmed there's liquid water on Mars. And you're often, I've been asked, does having water on Mars, is that going to help us get to Mars someday? And the answer is probably not. But, if they found money on Mars, that would really help. But I'll take your questions. Anybody? Yes, right here. Did I ever feel like I was going to die in space? All the time. No, actually, to be honest, you realize it's dangerous. One launch on the space shuttle, just one flight, is almost as dangerous as storming the beach at Normandy on D-Day. It's almost that level of risk. It's like pulling a card out of a deck of cards, and if you pick the wrong card, you die. Those are the kind of odds. But, we try to make it as safe as possible. We focus on risk and risk management and safety in everything we do. So we try to make it as safe as possible. But it's dangerous. I mean, a trip to Mars like this would be dangerous. When Neil Armstrong and Buzz Aldrin and Mike Collins climbed into their spacecraft in July of 1969 to fly to the moon for the first time, they all talked about this right when they climbed in, and they figured 50-50 chance Mike Collins has to come back by himself, and Neil and Buzz die on the surface of the moon. That's what they thought. Yeah, next to him. I read some science fiction. I read half of this book, maybe a quarter. I have a short attention span. But what's the great thing about this movie? It's a movie about solving problems and solving problems with engineering. And I imagine you get a lot more detail in the book. I have all kinds of questions about this movie. I think it's one of the best space movies ever. If you don't count Apollo 13, that's really good, The Right Stuff. They're kind of more documentary sort of movies, like factual. But for a science fiction movie, this is one of my favorites. But where do you get all that plastic from? Right, like 1,000 square feet of plastic? Where'd that come from?
So the question's about the astronaut corps. In this, there is this sort of kind of wisecracking, teasing each other kind of life. Then when you look back at the earlier representations of NASA at the time, it's a pretty straight-laced kind of a situation where everyone is sort of like, does he do right?
This is more accurate, with one exception. That's one of the things I thought was really great about this movie, is the relationship among the crew members, with one exception. I'll tell you about that in a second. The relationship with the crew in the Mission Control Center and the head of flight crew operations, which was the guy with the accent, the Scottish guy, who also, by the way, for some reason was also the flight director. That doesn't make a lot of sense, but that's in a movie anyway. The relationship between him and the public affairs officer, and then with the NASA administrator, who, by the way, doesn't actually live in Houston or have an office in Texas. That's a little odd, too. But those relationships seem very real. But the crew calling Jessica Chastain Commander Lewis all the time, that's not real. But the rest of it just seemed very authentic to me. How about all the way in the back, with your hand way up, black shirt, woman?
So, the intricacies of the spacesuits, with all the bells and whistles and whatnot, is that actually what you guys deal with? Not the one where they fly out into space, but when Mark Watney is going out onto Mars, is that anywhere near what you guys are?
Well, we have two spacesuits, but our spacesuit that we use for launch and landing is not designed to walk around on a planet. So it doesn't have these suits, like our space walking suit, the big white suit that we'll wear when we do a spacewalk outside of the space station. That suit scrubs carbon dioxide out of the air you're breathing. It provides you with a pressurized atmosphere. It provides you with cooling. On the surface of Mars, that suit has to do the same thing. There's a little bit of an atmosphere, so it has to do less delta pressure, right? So it's probably a little bit easier there. But, you know, I thought there were some really interesting things about that. You probably, I don't know if anybody in here noticed this, but a couple times when he would check to make sure the pressure in the airlock went to 100% after he repressurized. You ever notice he would double check and look on his suit to see what the outside air pressure was? So those things like that are pretty accurate. And if you were to build a suit for Mars, it would be like kind of like that. It would be, you'd be very mobile, you know, not cumbersome. Martian gravity is 1/3 of the Earth's gravity. So you know, you would want, it doesn't have to be incredibly light, but you wouldn't want a 300-pound suit like the ones we use in space when the suit doesn't actually have any weight. So I think it was pretty close. Yeah, right back here, guy.
Yeah, Mark, have you ever considered running for the presidency?
No. That looks like a really hard job. This is a lot easier. Yes, ma'am.
How are you psychologically prepared for any of this?
You know, I think they try to do a good job picking people, right? They pick a lot of like guys like me, test pilots. It's harder for the scientists and engineers that they're selecting. It's a little trickier for them to try to figure out and find the right people. But let me give you an example of like one of my favorite other astronauts who's not a pilot like me is a guy named Drew Feustel, who is a geologist, right? He's not a typical scientist. He's a geologist, but he went to community college before he got his PhD from Purdue. He also, in community college, he learned how to fix cars. And before he went to college, like, you know, to get a bachelor's degree, he was an auto mechanic, repair guy. So you see a guy like that who you're like, man, this guy has a PhD in geology, obviously very smart, but at the same time can really do stuff with his hands and it would be really good operationally. And that's kind of what we look for, are people not just that are good, you know, technically like book smart, but are actually good at doing things. Yes, right there. Yeah.
The movie had a lot about problem solving. Can you talk about a time that maybe something didn't go as planned when you were in space and how you problem solved?
Yeah, I mean, we have stuff break all the time on the space shuttle. Like during liftoff, 5 launches I've done, every time going uphill something breaks, some alarm goes off. You got a leak, get the SRPs, don't shut down, one burns out after the other and the thing starts rolling and yawing and it starts to get a little bit, you know, crazy. So that happens. And then, you know, in space, on the space station, I mean, or on the space shuttle, we get holes in the bottom of the space shuttle. We get to decide whether we're going to repair it or not. Mission Control Center helps with those plans. Before a spacewalk, we had the battery charger that charges the batteries for our spacesuits that we need to do these spacewalks, those big white suits, right? Those suits have batteries. The battery charger had a major problem, and it was a serious problem. So myself and one of my crew members, we had to take it apart. We had to take the circuit boards out, and we had to modify the circuit board of this battery charger. We actually had to cut some, like a little resistor off and do a little soldering and add something here to repair. So we'll do like that kind of repair in space when we have, you know, major problems. My brother was trying to grow plants in space when he spent a year in space, right? So he was trying to grow these plants, and the plants would get all this fungus because they would have too much water, and then the Mission Control Center would tell him, okay, here's how you're going to water the plants now. And then they would dry out and almost die, and he would say the plants are dying, and then they would change it again, and then they'd have fungus again. Finally, he said, please, just let me take care of the plants, and the plants will be fine. So they did, and he grew some lettuce and actually ate the lettuce. About right here.
Yeah, well, the movie showed a lot of the physical effects on being on Mars for almost 2 years. And I know your brother just spent over a year in Mars, and you both were in the same studies to study the physical effects. So what were some of the biggest physical effects for being in space?
So the question was, you know, they showed the physical effects of him on Mars, but he was actually starving. That was starvation. My brother spent a year on the space station. And the physical effects, yeah, I mean, it's been in space for a long time. The radiation is pretty significant. You get a lot of radiation, so we don't know what the effect of that is yet. We're going to find out here in the next 6 months to a year as they release this genetic and DNA and molecular information on the two of us. So we'll find that what that is. He didn't have a lot of bone mass because he did most of his exercise. He lost some heart mass, so his heart shrunk noticeably. He had major issues when he came back. He said at one point, a month after he got back, if he didn't know why he felt so bad, because he would stand up and he could watch his legs swell up when he would stand up. And he said he felt so awful, but if he didn't know why he felt so awful, he would have gone to the emergency room. That's how bad he felt. Yeah, right in the middle.
Here's a related question to that. So in the movie, they have like spinning, their spaceship spins, basically creating like artificial gravity. So how much of that actually might help against some of those negative zero gravity?
Well, it would help. Yeah, it would help a lot. I mean, if you could create, even if you could just create like a fifth or a third of the Earth's gravity, it would be an enormous amount of help. And I think if we're going to do missions, probably not a mission to Mars like this, but if we're going to do a mission that's like 5 years, or longer than that, I mean, I don't know. I mean, we could certainly get to like the moons of Jupiter in like, I don't know, must be some astrophysicist in here in like maybe 18 months or a year, something like that. We could get back. Beyond those kind of distances and duration in space, we would have to start to think about some kind of artificial gravity. But it's a big engineering problem, have this rotating, structure for this period of time, and things wear out in space with the radiation, and just the environment of space is very unforgiving. The white shirt.
Good evening, thank you so much. What kind of creativity and the tools and the resources do they give you in space? Like, I'm thinking my garage, my toolkit. What kind of stuff do you have up there?
Yeah, we have, on the Space Shuttle, we have a pretty incredible, what we call IFM, in-flight maintenance kit, and we have spare parts, and we can take things apart and repair them. I mean, we have wire to rewire things. We have, not only can we, like you would have a multimeter to do a lot of electrical work, but we also can, send voltages down wires, if we want to just rewire stuff, with a battery pack, and we can repower switches, and we do fly with spare parts. And on the space station, it's even more extensive than that. But I still don't get the 1,000 square feet of plastic. Why would you? Where would you have gotten that from? Yeah.
Will any of the medical data be available to the public?
It depends. So it's up to my brother and I. So far they've told us, like, genetically we don't have any major issues, and it doesn't matter so much to me. The people I'm concerned about are my two kids. One of them is sitting here, Claudia. Like, if there was some like weird thing going on with me genetically and I let that information out, somebody down the line might think, okay, there's a 50-50 chance she has that genetic disposition to something. And once the Affordable Care Act gets canceled and the pre-existing condition insurance thing goes away, we don't know what'll happen. So I've got to consider my kids in what we're going to release. My brother and I are likely to release all of it. I mean, at one point, my brother, they ultimately didn't do this, but scientists wanted to drill a hole in his head and put a brain port in to measure the pressure in his brain, and he agreed to do this. Ultimately, the NASA managers stopped it before they got out the drill. Yes, sir.
Just to mention, our first manned mission to Mars, do you think it's going to be a governmental agency like a NASA, or will it be private?
Question is, the first manned mission we do to Mars, is it going to be a governmental agency, or might it be private? I think it depends on the success of Elon Musk. And if he continues to be somewhat successful, he's landing his rocket on the barge that we all thought was pretty impossible to do, but he's done that successfully. And if the manned flights that he's going to kick off here probably in 2018, if those go well, and he has the financial resources to start a real Mars program. He's planning in 2018 landing his Dragon capsule unmanned on the surface of Mars. So this is going to be what looks like a manned spacecraft, like that MAV. He's going to land on the surface of Mars. And I think what you might see then is he forms maybe a collaboration with the government, and it becomes mostly government-run, government funding, but he becomes the contractor. I think that's a possibility. He says 2025. I'd be really shocked. I would think more like 2035, 2040. You know, the kid in the yellow shirt, you young lady, this guy, you could all go to Mars someday. Right, yeah, right here in the red hair. How would you test it? You know, we do a lot of, how would you test a spacecraft to make sure it's ready for space? So, you know, we run the real software in the real avionics. So in the real, like the black boxes that do all the guidance and the navigation and control, we set up the real boxes with the exact same wire and all the actuators, and we make what we call an Iron Bird spacecraft on the ground. And we test the real software in what seems kind of like a real vehicle, and we will test it for thousands and thousands of hours to make sure it works. Yes. Yeah. Yeah. You have too many questions? Two main. Give me one. Give me the first one.
My first question is, in this movie, it said that a certain point, Morgan's tired of the NASA is constantly making a move. Would you say that you understand that? And my second question is, how did you get involved in this?
Gary, what was the first question of it?
The second question is, how do you get involved in the space program, I think. And the first question, can you ask?
Well, how you get involved? Well, you're a little young still, but if you're interested, you got to study science or engineering or math or medicine. Pilot like me, is kind of a good way to become involved. But NASA has thousands and thousands, tens of thousands of employees around the country that do all kinds of things. Computer programmers. This mission actually had a computer scientist on it. We've never had an astronaut that was a computer scientist. But, when you see what happened on this mission, you're thinking, that was the other woman on the crew. So, to me, seemed like a computer programmer or a computer scientist. Probably a good person to have. Yes?
What do you think would be a good trade-off between humans versus robots on Mars, at least for now?
The question is, what would be the good trade-off between humans and robots, for now on Mars? Well, right now it's 100% robots, right? I think, ultimately it would be good to send people. Not just for the science part of this. I mean, yeah, a person on Mars, a geologist, could walk around and probably do more science on Mars in one day than a good geologist could. Right, Gary? Gary's a geologist. Could probably do more science in a day than one of these rovers can do in 6 months, I would think. But that's not the main reason to do it. The reason to do it is, we are explorers. The human being is all about exploration and pushing out with people. And if we do that, I really believe that it just, not only does it expand our horizons, but what it will give us in new technology and innovation and invention is just well worth the money we will spend on it. Yeah, all the way in the back again.
Sorry, I've asked a question before, but you and Gabby have gone through a lot this past year. So how do you mentally prepare to go back up in space?
Well, I don't go into space anymore. Like if I had to? It's a fun job. That's a long mission, though. The one crazy thing about this movie? Come on, they had two options, remember? And the NASA administrators say, no, we're going with option one. Option one made so much more sense. You got a dude sitting on Mars. You can send him all the food he needs until the normal mission shows up a few years later. He doesn't need to come back a year and a half early. Just leave him there. He's there already. So that, but psychologically, I don't know. I loved being an astronaut. I loved flying in space. It was my choice. I really wanted to do that job. It was so much fun. There was a lot of risk. You know, I think the hard part is like for my kids, for Claudia, for Claire. You know, they had to live through the whole Columbia thing where their friends' parents died, you know, on the spacecraft, and then I go back into space, you know, a year and a half later. So, you know, it's, you know, I think I'm just into space. You know, I'm a co-founder of a company here called Worldview. We're going to take people up, hopefully, into the stratosphere. You know, we will. We're taking payloads right now. We'll take people. You know, I will very likely do that. You know, if Elon wants me to go to Mars, as long as I can come back. For a while, he was saying these one-way trips to Mars. I'm not signing up for that. Right here. Have I ever been on the ISS? I'm only one of like 2 or 3 people that have been there 4 times. I'm the second person to be there 4 times. So I've been to the space station 4 different times. My brother, who lived there longer than any American, he hasn't been there 4 times. He's only been there 3 times. Yes. Yeah, so everybody knows who Albert Einstein is, right? He had this theory of relativity. It's also called now general relativity. It's proven. The faster you travel, the slower time travels. Proven. Speed and time are related. My brother has spent over 500 days in space traveling at 17,500 miles an hour. When we were born, or I would say when he was born, I was 6 minutes old. So I was 6 minutes older. And for our entire lives, I've been 6 minutes older. But now when you take into account my brother's 500, he has 500 more days in space than I do. I only have 50-something days over 4 flights. But he did 2 long flights. So where I used to be 6 minutes older, get this, now I'm 6 minutes and 5 milliseconds older than he is. So that's what the number is, 5 milliseconds.
You're working in space. How reliant are you on communication with mission control to do the repairs you need to do?
Well, so this is a little different, right? Because you got a long delay. They're talking 12-minute delay, you know, 7 to 12 minutes. So they've got to be a little bit more autonomous. You know, we are too, to some extent. I mean, but when we start to have problems with things, I got a whole team of people on the ground that's going to help me. And the relationship between the commander of the spacecraft, like me, the commander of the space shuttle, and the flight director, in this case, the guy with the Scottish accent, you know, or British accent, that guy, you know, it's kind of like your co-equals. It's kind of like your partners, where they have this team of people on the ground, you know, maybe 30 people in the Mission Control Center, but there's another couple hundred people supporting them. And then the crew in space, you kind of work this mission out as partners. Yeah.
Have aliens visited the planet, and have you seen anything funny?
Have aliens visited the planet, and have I seen anything funny? Well, you remember what I said earlier about Earth-like planets in our universe, like the potential? Like there are potentially more Earth-like planets than there is every cell in every human body on Earth. So it's a big number. So, but you also consider the distances. Remember I said Alpha Proxima Centauri, 4.24 light years away. It would take us 80,000 years to get there. So, you know, and but, you know, being in the Navy and being a test pilot in the Navy, you know, I have been to Area 51. And I can tell you that there aren't any aliens at Area 51 because they moved them to Area 52. Here. What does it feel like? I can tell you what it smells like. You know, space, there's nothing there, but oddly it has a weird smell. Like when we have people go do a spacewalk, and then they come back inside and we repressurize the airlock, and then we open the inner hatch, and I'll go in there and I'll grab them and I'll stick them on this rack with their suits, and you got to be really careful of touching the metal parts because it's minus 200 degrees outside. You could really like get cold burns on your hands. But when you open that hatch up, it has this really weird smell. It smells like burnt plastic. It's a really odd smell, and they think it's some atomic ozone that kind of floats around our Earth, even at 250 miles up. That's what the theory is. I don't think we really know for sure. But what it feels like, well, when you're outside, you're in a suit. It's a vacuum. There's nothing there. A couple molecules here and there of atomic ozone and other things.
So about the weightlessness, obviously you can have trained and have moments, when there's an apogee of a plane flying, all of a sudden you are, in theory, weightless. But how different is it to actually start living in a weightless environment? Can you be really trained?
Well, it's consistent, right? If you're doing that in an airplane, you're going from 2 Gs to 0 Gs, and it's really not 0. It might be plus or minus 0.1. But on the space station or space shuttle, when you're in orbit around the Earth, it's 10 to the minus 6. So it's 0 G. It's a millionth of a G. And it's consistent, right? It just is exactly the same. And it's pretty easy to live there. In some regards, it's hard to deal with a lot of objects at once. That's one of the problems with it. You can't put things down. They're going to have Velcro on them, or you're going to put them in a bag, and the bag has to be Velcroed to the wall. But the good thing is when it's time to move something that would be really heavy on Earth, as long as you're careful, you can do it by yourself. I remember one day, myself and another person we were going to install this rack in the Japanese module that we brought up, Japanese science laboratory, and other guy was busy, so I did it myself. The thing weighed 600 pounds on Earth, 600 pounds of mass, and I can kind of take this thing through one module into the next and install it as long as I moved it slow. Remember Newton's laws, those things. So it's kind of easy to.
But is the ease that you see these people move through the craft a fair representation?
No, that looks very awkward to me. Yeah, it's kind of like messed up. I don't know. Hollywood's been having a hard time doing this. That's why if you go on watch Apollo 13, that's very accurate because they filmed that in an airplane. All the way in the back with the phone. I thought that was another camera with a light.
So thank you first and foremost. One of the main concerns at the movie and the book relates to food, not only for Watney but for the crew. Towards the end of the book, there's a tiny, tiny, tiny mention of cannibalism. Has that ever been discussed as a tool for survival?
You mean like in survival school with NASA? Like, we do a lot of survival training. We do NASA survival training, Navy survival training. No. We've never talked about eating our crew members. We do talk about what you do when somebody dies. Like, we have a procedure on the space shuttle. It's in like the orbit ops, it's in the medical checklist. Like, what do we do with a corpse? We should have a body bag. On the space station, it would get even more complicated. Do you like cancel the whole mission to bring home the dead guy? Or do you just like stow him off into the side, right? What was that movie? Bob or something? What was that movie? Uncle? No. Bernie. Weekend at Bernie's. I think we would do that. There we go. Yeah, sir. Right there.
Thank you. Is there really privacy in the space station when you get a chance to have a video or even text chat with your family? Is that really private?
Yeah, in the space station, they have, every crew member has like their own little room. Now, the room is the size of a phone booth. It's real, or a coffin. One of them is actually called the coffin because they're one's on the ceiling, one is on each wall. This is in node 2, and there's one on the floor. And the one on the floor is the coffin. And then there's 2 in the space in the Russian service module. So there's rooms for 6 people. Is it what? Oh, data privacy, yeah. Yeah, you do, like I would do with my kids, even on the space shuttle, is we would have private video conferences. with the ground, or you can make a phone call, and that's private too. Yes, all the way back. Yeah, you looking behind you.
Hey, I came with my work wife today, and I need your help.
All right.
I'm sure you need to consider this very seriously. Ready?
Did you say your work wife?
So you need to consider this. Take your time. Star Trek or Star Wars?
You know, I know some people from each of those things, right? So I'm pretty friendly with George Lucas. Like Gabby and I have like stayed at his house with him and his wife, and you know, but as a kid, I watched Star Trek. Growing up, I remember being like 4, and my mom not wanting me to watch it because she thought I would like get scared from like the monsters or something. So I grew up really liking Star Trek. I never got like real crazy about it, but I always liked Star Trek. But what George told me once in talking about this movie is he made this movie for 13-year-old boys. And Star Wars came out, I think it was 1977. I was born in 1964. So I was a 13-year-old boy when that first Star Wars movie came out. So that meant a lot to me too. Yeah, yes, sir.
When you're dealing, not necessarily in movies, but like when you're dealing with people in regular life and they ask you about your job and stuff like that, what do you find is the most frequent or possibly most frustrating misconception about space travel that you've run into?
The most frustrating? Well, let me give you an infrequent but very odd one first while I think about this. I was getting off of an airplane about 6 months ago when my brother was in space. And I get off this airplane, and this woman stops me as I come out of the gate, and she says to me, she says, "You're on Mars." And I said, "No, I'm standing right here." And then she said, "Oh, it's your brother. He's on Mars." I said, "No, he's not on Mars either." So the most frustrating misconception, I would say, is that about 25% of the population, I hate to embarrass people in here, but how many people in here think the space shuttle flies to the moon? Okay, that's good. Keep your hands down. But if this was an anonymous test, 25% of you, maybe not in this audience, but 25% of the U.S. population, I'm convinced, thinks the space shuttle flies to the moon every time it goes into space. So that's kind of frustrating. And they think, so I get a lot of people that think I walked on the moon, like all the time. The last time somebody walked on the moon, I was in the 2nd grade. And I can sign up for AARP like 2 years ago. So it's that is certainly frustrating. Yeah. We actually think Mars might have been a lot more like Earth. The question was, do we think it was maybe a wet planet? There are signs that even now that there's some running water on Mars, and we think that Mars may have had a lot more water than it has today. And we also believe it had a much different atmosphere than it does today. You know, Mars has 96% carbon dioxide, very little oxygen, a little bit of nitrogen, where we are almost all nitrogen and 20% oxygen and very little carbon dioxide. So much different atmospheres. It would be good for us to understand why Mars is so uninhabitable now when we think it probably was a lot better to support life in its distant past. So that would be a good thing for us to learn.
You ever do any interesting experiments up there, just out of curiosity?
Interesting experiments? Yeah, we do. Space Station has 400 different experiments going on all the time. My brother was dissecting mice and rats in space, taking out their little mice hearts and their femurs and one eyeball and removing their blood like over and over again, you know, for science. You know, I've took mice on the space shuttle with me. We do a lot of science in space. Space Station is for science. Oh, personal science? No. I'm too busy. Yes.
I was wondering if you would give some background of the history and issues involved with women being included on the cruise, and also what would they have called Jessica Chastain's character?
They would have called her whatever her name was. What was her first name? The question was, what would they call Jessica Chastain? But the real question was a little background on women in space. So Sally Ride was the first U.S. crew member, astronaut to fly in space. But the Russians, the Soviets, flew a woman named Tereshkanova, who is still alive today. My brother knows her pretty well. She's in her 80s. She was a factory worker. She flew, I don't know, maybe like the fifth or sixth person, something like that the Soviets flew. When Hillary Clinton was younger, she wrote a letter to NASA, and she said she wanted to be an astronaut. How would she do that? And somebody from NASA wrote her back and said, we don't take women. But here's an interesting thing. We have this problem right now with crew members on the space station, that when they spend 6 months in space, and this is true with my brother, and with about 30% of the other crew members, after 6 months in space, they start to have major problems with their vision. They get these coronal folds in the back of their eye, and their optic nerve gets inflamed, and their vision starts to degrade. Like, I have 20/15 distant vision. My brother's like 2100 now. And we're identical twins. But he's flown many more days. But this is interesting. It only affects the men. It's not happened to a single woman yet. So maybe when we do this trip to Mars, maybe it's a crew of all women, if we don't figure out this whole vision problem thing. So, yes?
How do you guys acclimate back to civilian status after having been in space for a long period of time? How well does it happen?
Well, I think it depends on the person. You know, you're certainly happy to get back. You know, I think some of those guys that went to the moon really struggled. You know, after you go and, like, if you're Neil Armstrong or Buzz Aldrin, you know, how do you top that? You know, the first two guys to go to the moon. So they really, really struggled. I think it depends on the person. You know, I'm like one of those people that don't really look back.
Then coming back from Afghanistan or any...
Oh, no, you know, no, that's totally, totally different. You know, somebody who is serving our country in a war, especially a guy who served on the ground in combat. You know, I flew a lot of combat missions in Desert Storm, so I was always in my airplane when I'm getting shot at. But these guys, you know, Army, Marines, you know, Navy SEALs, you know, Air Force Special Forces that are dealing with this combat thing, that's really, really hard. I mean, the post-traumatic stress that they go through, I mean, that's really service. And I know we're a couple days after Veterans Day, but we really need to thank those guys for that kind of service. How about Gary?
First question, Mark, was with regard to, it seemed like to this young man that NASA was really trying to control Mark and he was resisting it. Did I get that question? And does that happen in real life?
Yeah, that happens. It's happened, you know, during an Apollo mission where, I don't want to go into details and you know, but where you get in a difficulty with your relationship with the Mission Control Center. That's happened in a space shuttle mission as well, more than once, and then the commander of that mission doesn't fly anymore, like he's done. So we have had those situations where, you know, the crew thinks they should be doing one thing, the ground thinks they should be doing another thing, the teamwork breaks down, and that affects the outcome of the mission. So yeah, I could see something like this, you know, like this happening. But the crew, in this case, it was a big decision. I mean, when she was saying this is like mutiny, she's not kidding. Yeah.
In the movie, they had the thing that really caused the problem, of course, is the windstorm, which there's not enough atmosphere on Mars to actually cause that huge windstorm that they had. But what would be the biggest threat to astronauts on Mars?
Well, I mean, the biggest issue is the radiation. You know, can you really handle that kind of radiation load for, you know, a long period of time? And that's why some of this information on my brother on telomeres, which is the stuff on your DNA, indicates your physical age and the damage to his mitochondria. You know, that stuff becomes very important. I think the radiation is a big thing. Certainly crashing into the surface of Mars would be really bad. That happens all the time with these unmanned spacecraft. Not so much with us. We have really, you know, the United States, we're actually pretty good at it, but everybody else just crashes into Mars all the time. So that would really be a sad ending to a mission, right, before it even got started. Let me take a couple more questions and we'll be done. 2 more questions. Yeah, all the way in the back. Hand up.
So there's a lot of talk about you going to Mars. Obviously, this is a movie about Mars, but wouldn't it be easier to go back to the moon and maybe try and test on the moon? And do you see us going to the moon first?
Yeah, the question is, you know, wouldn't it be easier to go back to the moon? We could test some stuff, and would we go to the moon first? Well, we certainly could do that. It would be easier. It's, you know, it's still a different mission. So, and I don't think, I think we are smart enough and innovative enough, and as long as we have the political and the will and the public behind us, we can make the Mars thing work. I think we can figure that out. And since we've been to the moon already, I'd rather see us go straight to Mars. It's my personal opinion. All right, last question right here, this guy.
Just like at the end of the movie, you see Mark becoming a teacher after being an astronaut. What do you think you'll be doing once you decide to stop your career as an astronaut?
Well, I left NASA in 2011. So, I mean, I, you know, have some, you know, relationship with the space agency still. I do some consulting for SpaceX. I do some consulting for another startup airplane company. I'm one of the founders of Worldview. But as a, like an instructor of astronauts, I was like an astronaut instructor. That's actually a real term. I did that, you know, after I was a commander of the Space Shuttle, you know, for a number of years, and I don't live in Houston anymore. So it's, you know, it's just something I've kind of put behind me, and, you know, I'm trying to contribute in other ways. But we can do this. All it's going to take is for you guys to want us to do this, or we just have to find money on Mars. Thank you very much. Thank you.